In these next few lessons, we're going to be talking about quadratic equations. When we had an equation where our x was to the first power, that was a linear equation, and we ended up with x equals a single number. And our process there was to isolate the x on one side and isolate all the other numbers on the other side. In our next few sections, we're going to be looking at quadratic equations. A quadratic equation is an equation in which the highest exponent on the x is a 2, x squared. If it's written in this form, this is what is called the standard form of a quadratic equation. B can be 0 and C can be 0, but A cannot be 0 because then, if that part weren't there, it would be linear. So we have to have the ax squared part, so A cannot be 0. And we're going to see that there's going to be several different ways to solve quadratic equations. So we're going to kind of be creating a flow chart or a thought process on how we're going to solve each quadratic equation. So the first one we're going to look at, the first way we're going to look at solving a quadratic equation is if there is no bx term. In other words, if b is 0. And we're going to use a specific process to solve equations that look like this. So our first step, if there is no bx term, for instance, let's say that we have an equation that looks like this. X squared minus 12 equals 0. Notice we have the x squared term and we have the constant term, but we don't have the term with just an x in it. So there is no bx term. We're going to isolate the x squared term. In other words, get everything else on the other side of the equation. And then we're going to take the square root of both sides. But we're going to see with a quadratic equation, we have two answers usually. Sometimes you have one answer that's repeated. So we're going to have the positive value of that number and the negative value of that number. For instance, 2 squared is 4, but also negative 2 squared is 4. So our first step is isolate the x squared term, so we add 12 to both sides. Then we take the plus or minus square root of both sides. And on the left here, we're just going to do the square root, but on the right, we're going to take the positive and the negative values. So the square root of x squared is x, and we have plus or minus square root of 12. Now we're going to want to simplify any square root where we have a perfect square under it. So we know 12 is the same thing as 4 times 3. So we can take the square root of the 4, which is 2, and then the 3 is stuck underneath because it does not have a perfect square. So the square root of 4 is 2. The square root of 3 is just left as square root of 3. But we want to get in the habit of always writing this as two separate numbers. So we have negative 2 square root of 3. We also have positive 2 square root of 3. And both of these numbers are solutions. So if I plugged either of those numbers back in for x, I would have a true equation. Let's look at another one. Let's say we have 4x 4x squared minus plus 9 equals 0. So I want you to follow those two steps. I want you to first of all, we look, it's a quadratic equation because the highest term is squared. It's an equation because it has an equal sign and variables and numbers, no f of x or y. So our instructions would just say solve, and that would mean find the value or values of x that I can plug in to make this a true statement. And because it's quadratic, I'm thinking I'm probably going to have two answers. So I look to see I do not have a bx term, so I isolate the x squared, and then I take the plus or minus square root of both sides. Pause the video and try to work this one. All right, so I'm isolating the x squared by subtracting 9, and then I need to divide by 4. And now I'm going to take the plus or minus square root of both sides. All right, now on this one, we have a minus sign under the square root. This plus or minus outside does not affect this minus sign inside. They have nothing to do with each other. That minus sign cannot just come out and be affected by that. Remember that we have our complex number I, which is equal to the square root of -1. This is by definition. So whenever we have a square root of a negative number, we know we're going to have an I in our solution. You never leave a negative under a square root. You always replace it with I. And notice that the I includes the square root. So when I am solving this, I have plus or minus, and then this negative is the square root of -1, so I have an I square root of 9/4. And remember, when you take the square root of a fraction, you can take the square root of the numerator and the square root of the denominator. So the plus or minus I comes on down. Square root of 9 is 3. Square root of 4 is 2. And you normally write a number in front of the I if you have a number. And we have two different numbers here. We have -3/2 I, and we also have the +3/2 I. So our solution here, our two solutions here, are -3/2 I and +3/2 I. Let's kind of recap what we did here. We looked at the equation. We saw we did not have a bx term. So our process is to isolate the x squared plus or minus square root of both sides. And then as we were doing that, we saw that we had I have no idea where this box came from. I don't know how to get rid of that. Oh, there we go. All right. We saw that we have our plus and minus versions. And because we had a negative under the square root, that gave us our I, because that's the same thing as square root of -1. And then we took the square root of the numerator and the denominator, and then we reformatted it as two answers with the number in front of the I. In our next video, we're going to look at how we solve quadratic equations that do have a bx term. And we're going to see that we have several different ways of doing this. And we'll continue our flow chart, our thought process here, with what do we do if there is a bx term?